Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And like we always do, we are reminding you to subscribe. And it's me, Richard, behind the channel. Tonight we are looking at this question. It says, two crates, 10 kilograms and 15 kilograms, respectively, are connected by a thick rope. Okay, this is the setup. So a force of 500 newtons is applied. The boxes move with acceleration of 2 meters per second squared to the right. Okay. A third of the total friction force acts on the 10 kg and 2/3 of the total friction force acts on the 15 kg. So the question says, calculate the magnitude and direction of friction force. Okay. So when you look at this scenario, what do you do? How do you go about it? Okay. The first step is to have the free body diagram. Let us start with the 10 kg. Okay, when you look at it here, what are the forces which are acting? You have the tension and you have the friction force. And with that, what do we do? You have the equation. The equation says F net is equal to MA. And do you know the mass? Yes, the mass is 10 kg. And the acceleration is 2. That gives you 20 newtons as the net force. Okay. Then from here, what do we know from the forces? From the forces, we know that net force is equal to T cos 0 degrees plus Fk cos 180 degrees. What does this give you? It gives you T minus Fk. Okay. So when you come and substitute in that, what do we know? We know we're going to have net force equals to T minus Fk. So when you substitute in, F net is 20. T, we don't know it. And Fk, we know it is a third of the total Fk. And with that equation, we can call that one equation 1. Okay. So what do we do next? Next, you look at the free body diagram of the 15 kg. Okay. It has that force. Let us call it force applied. It has the string which comes with tension. And there is friction force as well. Okay. So with that, what do we know? But you have to remember also here that F net is equal to MA, which is equal to, what is M? 15 times 2. So from here, you have also to remember that from the forces we have here, F net is equal to F, because the body is moving to the right. So F net is going to be F cos 0 degrees plus T cos 180 degrees plus Fk cos 180 degrees. So from here, what do you get? You get your F net giving you F minus T minus Fk. Okay, that's substituting with what we have. We know F net is 30 from there, and the applied force is 500. T we don't know, but we know that this one is 2/3 of Fk. Okay, from what we know here, if you get from the equation 1, we know that T is going to be 20 plus 1/3 of Fk. While from this equation, our T is going to be equal to 500 minus 2/3 of Fk minus 30. But you have to remember that this T is the same as this T. I mean, the T from equation 1 is the same T in equation 2. So when you equate them, what do we get? We are going to say 20 plus 1/3 Fk, which is equal to 500 minus 2/3 Fk minus 30. And from here, what do? You collect like terms. You put Fk on one side, and what are we going to get here? We are going to get 1/3 Fk plus 2/3 Fk is equal to 500 minus 30 minus 20. So when you sum up this one, what do you get? You get Fk. And what do you get from here? We get 450 newtons. And they wanted the direction. What's the direction? Applied force was moving to the right. Yes, to the right. So our friction force, remember, it must oppose motion. So it is to the left. Okay. So with that, let us look at the last question of this. Yes. Then comes this question. It says, calculate the magnitude of tension in the rope. Okay, how do you go about this one? We do this by substituting in one of the equations for T. Okay, you can choose any, but let us choose this one for now. T is equal to 20 plus 1/3 Fk. Okay, so T is equal to 20 plus 1/3 times 450. Okay, when you 20 plus What do we get from here? It's 150. And what do you get out of this one? It's going to be 170 newtons. So what you have there is the tension in the string. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe. Bye-bye. It's me, Richard. See you next time. Bye.